Welcome all. In our today's video session, we'll starting with our new chapter of arithmetic progression, which is related to your class 10th mathematics. Okay, I think it's maybe your chapter number 8, right? So before we starting, think we have already learned in our previous classes. You can say in your grade 9 mathematics or grade 8 mathematics, you may have see many patterns, or you can say sequences of the number. So starting with our topic, that is sequence. What is sequence? The sequence is your arrangement of the numbers in a definite order according to some rules, right? So what does it implies? It is the arrangement of the numbers in a definite order according to some rules. So I'm taking one example for better understanding. Like, see, I'm taking one a sequence of number, that is 1, 4, 9, or you can say 16, 25, 36, and so on. This is a sequence. You can say it's a series of number. So can you see anything uh, in the which is interesting you may find? So what is this? What is it? It is a it's a sequence that is a square of natural number in the ascending order, arranged. You must correct it. Arranged in the ascending order. So by definition, so what is it? It's a arrangement. We have seen the arrangement in which order? That is in the ascending order, definite order. You have seen in the definition. So what is the rule? That is according to some rules, arrangement of numbers in a definite order. The order is, that is in the ascending order. And what is the rule? The rule is square of the natural number. So the numbers are arranged in the ascending order, and as per which rule? The square of the each digit is a square of an natural number arranged in a ascending order, right? So if I generalize any sequence, so I say if there are, I'm saying the first term or the first number can be denoted with a1. So every number, please remember, every number of a sequence is termed as, or is called as the terms. Okay, so a1 is what? It is the first number, or you can say it's the first term of any sequence. So like if I say a1 comma a2 comma a3 comma a4 comma a5, what are these? These are the terms of the sequence. Like this is your first term, right? This is your first term, this is your second term, this is your third term, this is your fourth term, this is your fifth term. Okay, so this is the general way to express any sequence, and termed as the these are called as the terms of any sequence, right? Okay, so what next? So what so what is the, if I say what is the fourth terms of this sequence, that is a4. In this sequence a4 is 16, that is this. So this is the way you can find the, you can say you can form any sequence. So I have written here some more examples. for your better understanding. So this is also a sequence which is arranged in a ascending order according to which rule? Can anybody guess? This is a cube of natural number, right? What about this? This sequence? This is a arranged in ascending order of even natural number, right? And what about this? This is your odd natural number, the sequence of odd natural number, whose first term is 1, and here the first term is 2, and here the first term is 1, that is a1. Okay, so what is this? Can anybody guess? Okay, this is your, this sequence is your reciprocal of the natural number. So if I want to express it in a general form, that is, which is called as your nth term, nth term of the sequence, it is noted by an. So can anybody find, can anybody express this sequence in a generalized form, or you can say in general algebraic form? So if I studying with the first example, this is your first. Okay, so what is this? This is your cube of a, the sequence is a cube of a natural number. So if I want to express it is a, express it in a nth term, then it can be expressed as n cube. So what is n? N is your natural number. This is your nth term. Nth term. For example, we have already learned how to express any sequence in the form of terms, that is a1, a2, a3. Okay, or and 1 2 3 are its terms. So if I want to find the first term of this sequence, what I have to do? I have to put the value of n is equals to 1. What will you get? You will get a1, which is equals to 1 cube, which is 1. What about n is equals to 2? You will get your second term, which is your 8. Similarly, if you put n is equals to 3, you will get your third term, that is a3, which is 3 cube, which is equals to 27. So this is the way you can find your any terms you want. You, it may be asked in examination that the nth term of any sequence is given. You may the examiner may want you to find your 18th term, or you can say 10th term, or whatever it is mentioned in the question. This may ask for the 1 mark, or you can say it may be asked for your MCQs, can be asked in the MCQs for 1 mark question, right? So this is the way to express any sequence in a nth term, right? So what about your second sequence, which is your even natural number? Even natural number. So the nth term of this can be expressed as a like a 2n, where n here is also natural number, right? So if you put the value of n is equals to 1 comma 2 comma 3, you will find a1, a2, a3, and so on. Similarly, or you can say you will get this, that is, you will get this same series. If you put the value of n is equals to 1, you will get your first term, that is 2, second term 4, third term 6, like so on. Okay, so what about your third sequence? Can anybody guess how to express its nth term? Since it's your odd natural number, it's a sequence of odd natural number in a ascending order. So nth term will be equal to 2n minus 1, right? N is your again natural number. If you put the value of n is equal to 1 comma 2 comma 3, again you will get your a1 comma a2 comma a3 and so on. So what will you get? You will get the same sequence, that is this sequence you will get, right? So this is the way you can form any another term just by uh, applying your mind. Okay, so now what is the nth term of the sequence? We have already learned nth term is your any term, you can say it is just to express any sequence in a journal form, or you can say journal form or term, can also be said that express and express any sequence, expressing any sequence in algebraic form. Okay, so I think we hope you understand this concept, that is an term of the sequence. Now this is a first example that maybe this kind of question may be asked, that is find the first two term of the sequence whose nth term is given as an is equals to 2n square minus 1. So what will you do? First two terms means you have to find a1 and a2. So in order to find a1 you have to put value of n is equals to 1, so 1 square minus 1 which is equals to 2, so a1 is equals to 2. What about a2? You have to put value of n is equals to 2. What will happen? It will be 2 square 4, 4 to the 8, 8 minus 1 is equal to 7. So second term of the AP is 7. So this kind of question may be asked in your examination for a 1 mark. Okay, right? So like this, find 18. 18 means the 18th term is to be find out from the given nth term of the sequence. So what will happen? You have to put value of n is equals to 18. So find the value of 18 like this. Put the value of n is equals to 18. 18 is the 54. 54 plus 4 is equals to 58. This is the 54. 54 minus 4, it is 50. So it is equals to 29.25. So this is the 18th term of the given sequence, the nth term which is given. Okay, now the next part of the discussion, our discussion is the arithmetic progression. What is this? This is a particular kind of sequence, you can say, in which each term excepting your first term progresses in a definite manner. Okay, for example, I'm giving one example of AP from which we will generalize its definition. Okay, like this: 1 comma 3 comma 5 comma 7 comma 9 comma 11. What is this? It's a sequence of your odd natural number arranged in a ascending order. See, except your first term, see, every other number is every other number, or you can say excepting your first number, is 2 more than the preceding term. See here, your second term, that is a2, is 3. It is 2 more than the preceding term, that is a1, or you can say a2 is a1 plus 2, right? Similarly, you can say that a3 is also 2 more than, it is 5, which is 2 more than a2, or you can say a3 is equals to a2 plus 2. So here you can see that every term is 2 more than its precedence term or preceding term, right? So what does it implies? If I generalize the definition again, so what is the AP? The AP is your sequence. If there exists a constant number, you can call it as a D, such that such that such that your AT is equals to A1 plus D. Similarly, A3 is equals to A2 plus D. A4 is equals to A3 plus D, like this. Or you can say your nth term will be equals to an minus 1 plus D. So what is D here? D is a constant number. You have seen that in your, I'm writing here again, sorry, this is your constant number D. We have seen in our AP, or you can say sequence of the odd natural number in ascending order, your constant number is, you can say D is 2. Okay, so constant number, or you can say D is your common difference among the terms of the AP. AP is your arithmetic progression. So I hope everybody has understand the concept of the AP, which is a particular kind of sequence, right? So now the next part, that is show that a sequence is an AP if its nth term is linear expression in n, and in such a case the common difference is equals to the coefficient of n. Okay, it's saying that any sequence which is in a linear expression. So if I assume any sequence whose nth term is a linear expression of n, if I assume that any I assume C and D, suppose, are the constants, or you can say are the coefficients Cn plus D. See here, I have expressed it in a linear polynomial, right? We have already have a chapter on the polynomial. So this is your polynomial in n, which is a linear polynomial, as it's having a order of 1. So it's a linear polynomial. So in the question it is given that the AP, any sequence is in a linear expression in n, right? So I assumed that an is equal to Cn plus D. You can also assume like this, Cn plus D plus 4, whatever you like. So you will get the same result. What we will be, what will be getting now? So what does he want us to prove? That show that a sequence is an AP if its nth term is a linear expression in n, which we have already assumed, and in such a case the common difference is equals to the coefficient of n. Coefficient of n is your C. He want us to prove that the common difference, which is D, is equals to the coefficient of n, which is equals to C. We have to prove that the common difference is equals to D is equals to C. So how will we find out the common difference? We have already learned that your A2 is equals to A1 plus D. So you can first find out your A1, which is equals to C multiplied by 1 is equals to C plus D, and A2 is equals to 2C plus D. So you can say that A2 is equals to, oh sorry, D is equals to A2 minus 1, as we have already see here, we have already learned this concept. So your a2 is equals to 2c plus d. A2, put the value of a2 here and put the value of a1 here, c plus d. What will you get? You will get d get cancelled. 2c minus c is equals to d. Oh sorry, 2c minus c is c, so d is equals to c, which is true. So this is very generalized concept, or you can say very important concept. You have to uh, keep it in mind. It may be asked in your 1 mark question that if any sequence is given in a question which is in a linear form of n, or you can say which is in a linear polynomial of your term n. So in that case you can directly the question, in the question it may be asked to find your common difference. So how to find it? You can directly check the coefficient of n. The answer will be your that coefficient of n, which is equal to c, or in the question the n term may be given like 3n plus 2, and he want us to find out what is the value of d. So d here is equals to coefficient of n, which is equals to 3. So this is the direct conclusion we have find out. Okay, so I think this is sufficient for this video session. We will come along with more examples and questions. We will solve your previous year's question as well in your next section. And please don't forget to like and subscribe my channel and share it at the max. Thank you.